Some more examples of strings and using the plus operator or joining the strings. Let's start with example right here. I'll remove these earlier examples, and here's the challenge. So I have something like this: hello, which is a string, and operator plus a numeric value such as 12. Both strings and integers, of course 12 is an integer, are part of the Java programming language. So Java compiler has to make a decision here what to do about this this situation where we are trying to mix a string with our other data types. In this case, it's a primitive data type is an integer. Well, there could be two choices: to use an arithmetic plus, but that doesn't make sense because hello is not a number. So the decision here is to use string concatenation. It means that this is equivalent to doing this, basically using 12 as a string. So an integer is converted to a plain string before this concatenation takes place. So let's try to validate it and try to let's do it both ways, like this. Right, so this is 12 integer and 12 string. So let's run it. You can see the outcome exactly the same, hello 12, in both cases. So essentially, once again, in case of an integer used with concatenation with strings, the integer is first converted to a string, to its text representation, and then concatenation is taking place. Let's also make sure that the other type of positioning works. So if we try 12 plus hello, and this is pretty much the same, let's just try this and make sure that this works the same way. When we place integer in the first place and a string in the second place, we run it, we see that this is exactly the same way as if we used a plain string. So the integer is converted. So this is a property or behavior of string concatenation operator, that it works this way with primitive data types. So this is not all that bad, but if we go back to the original example right here, and if we try to use some more math right here, and say, like in this slide, we have another number like 26. So again, sometimes you need to think like compiler. What compiler does here is, as before, it starts with the left-hand side of this expression using plus, finds out that this is a string object, and then it has an integer. So it does its thing. It basically first it converts 12 to a string. What do we get here? This becomes a string like this, and therefore then we continue exactly the same way, and this becomes what? It becomes another string. So the outcome of this is, as indicated by our slide, is that it's equivalent to printing something like this. So instead of arithmetic addition, we just execute subsequent concatenation of integers converted to strings, and we still have plain vanilla string concatenation and no math. So if you want to change it, so I'll just undo my thinking right here. So we have these two numbers. If you really want to do a math that should add these two numbers together, you have to group them. In this case, whenever the parentheses are present in our code, compiler has no choice but to decide what is happening inside the parentheses before anything else happens. So of course it sees two integers and the plus between them. So this time surely it will add them together. This will become 38, and then hello will be concatenated with 38. So it should print hello 38. String class is one of many Java classes stored in Java application interface. However, we don't need to import any string objects from the library because it comes with the language package. So it's just sort of like built into the language because of a high popularity of strings. So I already showed how to join strings or concatenate strings. These are just other types of examples. And of course, strings can be concatenated not necessarily with integers, but with other primitive data types and with other strings. So here we have an example of a double price concatenated with text price. And of course, it does its concatenation. So the plus operator just uses, here we use more examples of very, very similar application of it. Except that perhaps here it's interesting to observe this last statement. We have a name. Let's just use this example right here to demonstrate. So Bob is a string, and we construct this string at the beginning of our code. So this is what name reference get to point to. Then we use it again. Of course, it's pointing to the same object, and we construct another string. So this literal string constructs an object like this. So it corresponds to this object. And the result of this concatenation, when we concatenate these two, of course, is a combination of both. So we get a longer string right here. And we assign it back to the same string reference. So the string reference gets adjusted, and it's now pointing to a brand new object. So both of these were used only on this line and on this line, and there's absolutely no way again to gain access to these two original objects. So they're free to be garbage collected or destroyed. They will be no longer used, and their memory could be freed and returned back to the system, because as indicated by this code, we no longer really retain any references to these original strings. We combine them together, we construct them and combine them together only to construct this brand new string, and we reuse this string reference. So it's an interesting observation that string reference could be pointing to one object at one point of time, and later on can switch to point to a different object. So this is again the behavior of object references. They refer to a certain object, but they could change and start pointing to something else.